Hi, thanks for having me, and thank you for tolerating me talking about CSS at JavaScript conferences. It really is my favorite thing to do, to come and talk about this stuff to you guys, because I feel like I've found my people. So thank you for your patience with that. Today I'm going to talk about CSS Lint for massive websites. My name is Nicole Sullivan, and I tweet at Stubbornella here. It's probably the best way to reach me. It turns out I reply much more quickly to 140 characters than gigantic emails. So I work for generally bigger companies when they realize that their CSS has gone completely mad and completely out of control. So right now I'm consulting with Salesforce and Box.net and a few other places, basically trying to pare their CSS down to something more reasonable. And I asked this last year, and I'll do it again. How many people have found that they were building something and the most painful part of it was writing the CSS as opposed to the JavaScript? Yeah, that can happen, definitely. Especially if you're more comfortable coming from the programming angle, the CSS can seem really unintuitive. But I think we can make that better. So a little bit about CSS. Much like JavaScript, it will let you do absolutely anything, no matter how stupid it is, no matter how bad an idea it is. So you can get very excited and gleeful, and yet you can be completely breaking everything. The point of it is that we don't have to do stupid things just because we can. We can resist. We can decide that we are not going to do the thing that's going to end up with really bad results. So what is object-oriented CSS? It's sort of a nutty idea that we can build CSS with engineering best practices in mind. No, it's not a one-to-one correlation. It's not like you can just apply something from programming to a declarative language and think it's just going to automatically work. There's a thought process involved. But OOCSS is about sort of saying, we can do better. We can take a look at engineering best practices and figure out how that's going to make our CSS development better. And we absolutely can. It is definitely possible to make your CSS development more logical, more reasonable. But I'll warn you, the language doesn't give you any help with that at all. There are basically no constructs built into the language which will help you make anything object-oriented or even remotely good programming, really. So the only thing that really will make that happen is developer discipline, basically deciding what your team CSS is going to look like and sticking to it. So why bother optimizing CSS? Stoyan Stefanov and I have done some research, and I'm going to share with you some of the results that we got about what happens when CSS is unoptimized, and our experimental results from the Alexa Top 1000 websites. The basic reasons are because it blocks progressive rendering. So if you've ever, can the microphone be a little less loud? I'm bothering myself with it. I can't imagine how you guys feel. All right. So if you want to go visit this page that I have a link to, you absolutely can. It basically shows how CSS blocks progressive rendering, except in Opera, it basically will show a blank page to the user, which will be completely white with nothing on it until it's downloaded and processed all the CSS files. The only browser that doesn't do that is Opera, so compare it, visit this URL, compare it on Opera versus other browsers, and you'll see that we're actually giving users a pretty bad experience when our CSS is too big or we have too many files. The other reason is because it's verbose. There's really nothing we can do to make CSS smaller. So whereas in JavaScript we can make all our variables shorter, we can compress it in all kinds of interesting ways, for CSS that just doesn't work. There's no way to do td:\u and have it know that that means text declaration underline. So it's important to actually write it small from the get-go. But sort of more importantly is what it does to your team's development and the sort of mess it can cause with the way that your team works. One client that I worked with, basically they were a startup, and I think this happens a lot, especially for startups, is that you're so busy trying to get the next feature out there, trying to meet the next release, and to to kind of beat your competitor and to be the next one to have the cool thing that's going to bring users to your site, that you don't necessarily have the time to reflect and to pull back and to say, is our architecture making sense? So basically, it can happen that a client can get themselves painted so badly into a corner that a feature that should take 2 days to release actually takes 2 weeks because they spend that much time just trying to get the new feature not to break when it's inserted in their actual site with their actual CSS. So I think, yeah, there are definitely performance benefits to getting your CSS figured out, but the biggest benefit is spending less time writing CSS and more time writing stuff that's going to actually add value for your users. So last year, Facebook decided that they were going to go on a diet. They realized that their site speed was not what they wanted it to be, and they made a big commitment to fixing that. And CSS was sort of one part of that puzzle. And they hired me to come in and look at their CSS at that point. Just before I started, I went to Velocity Conference and I heard 2 of their engineers, David and Chang Hao, talk about their haste-based packaging system. It is a really neat idea. Basically, they parse their logs and they figure out which files are requested together most frequently, and they build those into packages automatically based on the previous week's logs, which means there's none of this sort of, wait, should I combine these 2 JavaScript files? Should I combine these 2 CSS files? They know what to combine and what not to combine based on their actual usage patterns. Really super cool idea, which had unintended bad consequences. After a year of using the system, they had 1.9 megabytes of CSS and 706 CSS files. It basically made it far too easy to do the wrong thing, and so everybody did the wrong thing. This was what I sort of started out with when I went to consult with them. Now, their performance group had a lot of different angles they were working at. They were working on BigPipe and XHP and a bunch of other things, some automated spriting, which works similarly to the packaging system, where they're actually figuring out which images are requested together and sticking them into sprites, modifying the CSS automatically. Really cool stuff, lots of different pieces coming together. The end result was that they reduced their response time in half in only 6 months. So that's a pretty important gain. And I'm going to talk to you a little bit about how I did the CSS piece of that puzzle. And definitely check out their engineering blog to hear more about the other parts of the equation. So today we're going to talk about the state of CSS performance, building a component library, integrating components with an existing site, and then things machines do well that people kind of suck at. I'm going to tell you first about sort of how I did this stuff by hand at Facebook, because at that point I didn't realize that some of this could be automated, and then talk a bit about automating it. So the state of CSS performance, it really isn't, a very pretty site right now. Stoyan Stefanov and I this summer did some research where we pulled down the Alexa Top 1000 websites. Can we fix this? This is awful. It keeps moving. Sorry about that. I'd rather fix it and get it over with.
Maybe we can from this here.
Is it?
It's going to stay there. So it should be work now.
Okay.
Hold on a second.
But every time I breathe, I can hear it, and I don't like that. Okay, let's try again. No, it's still bad. Can I just bend it away from me like that? Is that okay? Can you guys hear me if I bend it away? Yay, okay, good. All right, so Stoyan Stefanov and I pulled down the Alexa Top 1000 websites, and we ran some tests on them, because we kind of wanted to see, well, we've been in this performance game for a while. How are things? How are people doing? How are these websites performing? What we found was not great. So I'll talk a little bit about the basics, then how I used grep on the Facebook website, and then visual inventory and eliminating inconsistencies. So the first thing is for the Alexa Top 1000, we basically grabbed each one of the Alexa sites, started Fiddler, loaded each site, and then exported the results from Fiddler. Stoyan has published the PHP that we use to do that, so if you're interested in running your own test, you can feel free to grab that and use it. It's available as well on my slides. What we found is that 42% aren't even gzipping. 44% have more than 2 CSS files. 56% are still serving CSS with cookies. So unless you're doing some kind of crazy pre-processing, there's really no reason to send cookies back and forth every single time with every request for the CSS on your site. 62% don't minify. The way that we determined that was if they got more than a 10% improvement from running the YUI compressor on their site, we considered them not minified. If you run it over and over, you will get some smaller diminishing gains, but we didn't want to count those really small sites in that figure. We also found that 21% have greater than 100K of CSS. So these things that I've just showed you, you can use YSlow or page speed to figure out where your site is at. There's stuff that we've known about for a long time, but as it turns out, we're still kind of screwing up. But when you want to test more advanced stuff, I find that grep is the best way to do it. Basically, I want to be able to look at all my style sheets in one go. The thing with the results that Stoyan and I got is that they actually underestimate the problem. Because any site that actually uses a packaging system, like the haste packaging system that Facebook created, is going to show a much lower amount because we're only going to ever see what they're pulling down on one page. So using grep, you can get the bigger picture of how inefficient your site is sort of globally. So of the Alexa Top 1000, we found the worst site had 733 floated elements. That's absolutely gigantic. But 14% had greater than 100, and, 13% had greater than 100, and 56% had greater than 10 elements. So that's pretty broken. What does it mean if you find that you have too many floats? Like, say you've heard me say you can go and grep your style sheets and you go back and you try it and you think you have too many. It means that you need a grid system. You need one consistent way of laying out your pages and then the interior parts of your pages that works site-wide so that you basically don't repeat that layout stuff in every single object. More importantly, you're going to need to realize that the cost for newbies joining your team is much, much higher when you have the layout information mixed in with all the rest of the CSS. It's like I don't know if this is the right word for it, but I think of it as kind of separation of concerns. We're trying to get each object that we build to solve one problem, solve it really well, and not try to do the job of other objects in the page. You can also grep for H1 to H6. This will tell you how many headings in your page and tell you a lot about the kind of duplication that you have going on. So Stoyan and I found that the worst website had 511 declarations of H1 to H6. But more importantly, I think, is this number down here. 56% have greater than 10. So more than half has greater than 10 heading declarations. Why is that a big deal? Well, think about it this way. Most sites are not going to use font sizes smaller than, say, 10 pixels, because smaller than that is sort of good for mice to read, not humans. And then, unless they're a designery site, they're probably not using greater than 24 pixels. So that leaves 14 pixels, 14 different font sizes that are usable. Then we look at the fact that you're not going to usually want to increment by just 1 pixel. If you put 13 pixels and 14 pixels on the same site, either the user won't be able, the best case scenario is that the user won't be able to tell the difference between the two of them, but the worst case scenario is that they notice there's a subtle difference and they kind of think it should mean something, but they're not sure and they're not really getting it. So if we consider that we want to increment by, in most cases, 2 pixels at a time, that leaves actually only 7 different usable font sizes on any one website. So in that case, we're seeing that more than half have greater than the number that they really need to have. When I worked at Facebook, the first thing I found when I grepped their style sheets was that they had 958 different H1 to H6 declarations. After we redid their style sheets, it was down to 25. So yeah, that's larger than the absolute number of 7 that we think we should have, but it's still so much better than where sites are starting from currently. So the worst site in the Alexa Top 1000 had 889 font size declarations. This is sort of, this is another way of looking at headings. You can look at H1 to H6, but it's also possible that people aren't using the correct elements. They're just sticking font size changes on a div, or that they've put it in a class. So grepping for font size actually tells you an even more exact picture of how many declarations you have and how many more than you should have. And this number is even more interesting, because when we grep for font size rather than H1 to H6, we find that we've got 78% of sites out there in the Alexa Top 1000 having more declarations than they really need to have. So if you have too many headings, what does that mean? Basically that you need site-wide heading objects, that you need headings that you can plug in anywhere and they're just going to work. You don't want to have a giant pink H3 and some user comes along, well, sorry, by user I mean people who are going to build HTML after you're done with the CSS, comes along and says, great, on my new page I also need a giant pink H3. They grab it, they paste it in their new page, and it completely explodes. This is what we need to avoid if we want to be able to have site-wide headings and avoid that kind of duplication. So the worst website in the Alexa Top 1000 had 518 margin resets. So by margin resets, I mean they set margin to 0. Basically, the exact thing that you would do with a reset style sheet, they're doing it over and over and over again throughout the site. And I see this a lot with sites that don't use a reset.css. My preference is the YUI reset because it's really solid and it doesn't do a lot of extra stuff that you don't necessarily want to have happen. Oops, I think I was supposed to have a number here. I forgot to get it out of my research. It was slightly less than the margins. I don't remember the exact number, but it was on the order of like 600 or something like that. Okay, so if you have too many spacing tweaks, reset.css is definitely your answer to get rid of the margin 0, padding 0. But if you find all over your site you're saying, okay, this, but actually add 2 pixels here, and that, but add 5 pixels there, you're also going to need some abstracted spacing classes which work basically like mix-ins, and you can apply them to existing objects to change your spacing. So you may not even know really what your site is made out of. A lot of people don't. I also think a lot of people have trouble seeing their site for what it really is. They're so busy looking at it and each feature means so much to them because they built it with their own hands that they really can't see the repeating patterns in their own site. So the way to start to see it is to do a visual inventory. A good way to think of it is kind of like Lego. So these crazy people built an entire car out of Lego. I couldn't believe it. Turns out they're just really neat stuff built with Lego. I like Lego Einstein as well. This guy, brickartist.com, he's doing actual art and sculpture out of Lego, like this poor thing that lost its arm. And he did this one as well, which reminds me of how I feel when I see 1.9 megabytes of CSS. There's a sort of panic moment where I think, oh dear God, can I actually optimize 1.9 megabytes of CSS? And just, okay, start, do the first bit. But this guy's stuff is really neat. The thing to keep in mind is that no matter what we've built out of the Lego, the fundamental building blocks are the same for all of them. And so what we're trying to do with our site is to say, sure, yeah, we have a Lego Einstein, but what do the bricks look like? What do the little building blocks that we made it out of look like? So we want to do exactly the same thing with CSS. You are going to be tempted. How many people do back-end code as well as JavaScript and front-end stuff? Okay. You especially are going to absolutely be tempted to have PHP objects have a one-to-one correlation with CSS objects. And you're going to want to say, you know, pound my really fancy feature and then all the CSS that goes with it. Don't do it. It's a trap. Each layer in the architecture needs to have its own, its own way of functioning. Basically, well, it's kind of like if you took the DB schema and tried to configure Apache with it. You can't do it, right? But yet we expect the PHP architecture to inform the CSS architecture, and it works just as poorly. Oh, and well, so I think to be fair, whichever layer you're most comfortable with, you kind of project it onto the other layers, because when I was at Facebook, I often wanted to make the PHP match the CSS. Luckily, I worked with really smart developers who didn't let me get away with that, but that was sort of my first instinct, so I think it goes both ways. So let me show you a practical example. Is everyone familiar with this? It's a stream story on the Facebook website. So in the PHP, this might be one object, stream story, and it's built and it has comments, and so there's, you know, me saying something at the top and a couple of people liking it and then me talking to myself below it. And in the PHP, that all fits together as one object, right? In the CSS layer, it isn't one object at all. It's actually a bunch of smaller objects. And if we break it down to that level, our sites will start to look like repeating patterns. So here's what I found in this particular object. We have one heading, so it's my initial thing that I said, and then we have 5 media blocks. A media block is basically an image to the left and some stuff that describes it to the right. If I had to pick one thing that the web was made out of, visually speaking, it's that. We have a comments list, an action list, a paragraph, and a couple of link styles, a normal link style and a highlight link style. So you can imagine how if you start to break things down to this level, and it's about taking these little components and arranging them in different ways with our grids, all of a sudden most sites are actually built out of exactly the same stuff. And there's this tiny little thin layer of Chrome, which does colors and images, which is different. But other than that, our sites are the same repeating patterns. So it's all about pattern matching, but you have to be willing to take a step back. You have to be willing to, and it might help maybe if you have somebody who's never looked at your site help you do it, because it can be really hard when you're sort of in the trenches to figure this out. Also, most sites get the granularity wrong, and the architecture is basically set up to fail. If you find your CSS is growing and growing and growing over time and getting more and more unmanageable, probably your architecture and your granularity is wrong, and you basically can't fight it back. You have to get the basic part right in order to make it grow nicely. So I want to make you try it, just so that you'll have a little experience with it. What objects do you see here? One of you has to actually speak. I'm really, truly going to wait for someone to suggest an object in the page. Or I could call on you. Wouldn't that be awful? Dialog box. Rounded corner box? Or, oh, I see what you mean. Yeah, like a pop-up. Exactly. He said a dialog box. So it's true. There is in this a pop-up, right? Now, we want to be sure to separate out its pop-upness, the fact that it's in the center of the page and it has like a white transparency, like partial opacity that covers the rest of the page, from the fact that this one happens to have blue rounded corner box with a slight gray shadow around it, because that's a separate object. That's actually the contour. Okay. Tabs. Yep. Tabs are a container. You might very well want to have them somewhere else. You might have an instance where you need tabs in a page, or you need tabs in a different kind of rounded corner box. You definitely want to separate out the tabs into their own object. Good job. Yes, there are buttons. Absolutely. There are a couple different buttons, and in fact, when you hover over them, they have a couple of different states. So buttons are an important object to separate out. Sorry? Input fields. Yep, we've got input fields, we've got a text area and an input. We've also got labels. So those would be separate objects, or maybe together, depending on if there were different possible layouts. Link styles, yeah, exactly. We've got one link style, which is the basic link style, the change in the blue. And then up at the top, the help, we have a sort of low light link style as well. Good job. There are a couple more. Sorry? Yeah, there's a heading, absolutely. One important thing to notice about the heading is that it has a little image to the left of it. And you know, the media block we just saw in the previous example, all of a sudden, if we have a media block object which exists, which we can just use without having to write any CSS, and we have a heading object that we can just use without writing any CSS, all we do is insert our image and our heading into the media block, and we have that basic layout. Yep. One more? Sure, in the back? It could be, yeah. So we have a list here for sure. My thought is that it might be a definition list, just because it's sort of got like thing and then something that goes with it. But it could also be an unordered list, yeah, absolutely. So that's perfect. You guys are definitely seeing what this stuff is made of and how to sort of break it down. You'll definitely have more trouble doing that with your own sites because you're just more familiar with it, and that actually makes it harder. So I want to go through the steps to a good visual inventory and show you a little bit about how that works. First, you want to pick pages in your site that are kind of representative of the whole. You may have a site with thousands of pages. You definitely don't want to go through all the thousands of them. Then you want to go through the same exercise we did with the pop-up, but you want to do it with every single piece of your site. Copy them into a separate document, and the reason for doing that is because you're going to want to group them by type. You're going to want to group all the headings together, and all the link styles together, and all the tabs together, and the other boxes together, and the pop-ups together. That way you sort of get the idea when you have duplication and when you have things that are subtle variations on basically the same thing. What you have when you're done with this is sort of the very beginning of a brand new way of coding the CSS for your website. I want to show you an example of visual inventory results that I did. So I basically go through an entire site, or, well, in this case I did 12 pages. We were able to find 12 pages that sort of fairly represented the larger site. And you find all of the headings and text treatments. So this is an excerpt from the headings and text treatments. One thing to notice is if you look more closely, I think there were 7 or 8 different ways of doing dates in just 12 pages. So it can be really important to put them all together because all of a sudden you're going to find all these inconsistencies. And when I give this kind of thing to a client, the designers have this moment where they go, oh no, we screwed up bad, right? Because when it's all separated out into different pages, it can be really easy to think, oh, we have a pretty visually consistent site. But when they're right next to each other and you can see that you used 12 pixel 666 and 12 pixel 333 and all of the others, right away you sort of can't, you can't argue with that. So once you have that, once you have taken your visual inventory and you've eliminated the inconsistencies, you've removed all of the cases where you have something which is exactly the same or is just a very subtle variation on the same, you can start building your component library. And so we're building the Lego that are going to be used to build all of the features of our site. That might be headings, lists, contours, backgrounds, text treatments, tabs, carousels. There are a lot of different things, buttons, all the bits we found, form elements, spacing classes. But they have to be built well. And we want to look at the anatomy of a good component. What makes a good component? So an example from Facebook is the media object that I talked about with the image to the left and the stuff that describes it to the right. What I realized when I was looking at the Facebook website is that they had all of these different pieces, and if you use Facebook, they'll be pretty familiar to you, but they're actually all the same object. The image might vary, the image width might vary, but it's the same thing happening over and over again. So the first thing to do when you're building a component is to say, all right, what do we know about this component? What do we know for sure? It can be nested, right? We can see from this one here that it can have a media block nested inside of itself, so that's a really important thing to know about it. It has an optional right button, the little X to close it, so it actually has 3 regions, the left, right, and then the center area. And it must absolutely clear fix. We wouldn't want something sort of sliding up into the media block. Perhaps more importantly, we need to define what we don't know about the media object. This is where we make our components flexible, where we make them work in situations that we didn't originally intend them to. Keep in mind that you're not writing your CSS for where your project is now, to build the designs you have now. You're writing your CSS to build the designs you're going to have in 6 months' time that you have no idea what they're going to look like yet. So you're building the pieces that will make the features later. So what don't we know about this? The image width and decoration vary. You can have big images, they can have hover effects, you can have tiny icons. We really don't know what the image is going to look like. The right content's also unknown. You can have lists in there, you can have paragraphs, basically anything can go inside of it. That's how we know where the boundary of our object stops. Because I could say, you know, media object, link, blue. But what I really want to say is the media object doesn't care what goes inside of it. So the boundary of the media object is the body area where you can place any content that you like, including other objects. And then the final thing is that the width is unknown. You'll notice that these are all different widths. Now if I said that the media object had to be 250 pixels, it could only be used in a space that allowed 250 pixels. By making the media object something flexible, even if it's going to then fit into a fixed width layout, I've made it something that can be used anywhere. We also want to separate Chrome from structure. It's a little hard to see on this slide, but these two media objects actually have a different background color. Now, the typical way we've written CSS is that we have one thing that we really like. We're like, oh, good, the code for this is perfect. And we say, oh, but we need a blue one. So we copy-paste the entire CSS over, and then we change the white background color to a blue background color. You absolutely don't want to do that with your components. You want to basically take off that layer, which is just Chrome, and apply that sort of like a mix-in to the base object. It's really simple. If we look at the code of the media object, it's just a few lines of code. It's a div, basically a wrapper element, with an A in it, a link, and an image inside of that. And then we have a body area, which is where our content of our media object will be. The CSS is also really simple. We basically have a new formatting context, which is the overflow hidden, overflow visible, zoom 1. There are a few different ways you can get a new formatting context, and the more application-like your site is, you will want to use a different one than this, but this works well for just sort of plain websites. And then it's pretty simple, a few floats and some margins and paddings to make everything line up nicely, and we're done. It's a really simple object. This is my stream story from the Facebook website, and this is my stream story with all the examples where a media object was used highlighted in red. So just this one object, we were able to have a huge impact in the amount of code on the website. Each of these before was coded individually. Each of them before was a separate instance, and all of that floating and margins was all repeated over and over again. So we got a huge performance benefit just from this tiny change. One thing that people will say as well, isn't your HTML going to be a little bigger? Because in the case with the icons, maybe we could have one less div or something like that. You know, in a perfect world where everything was coded perfectly, maybe that would be true. But in the real world, where stuff gets coded with all kinds of different levels of quality, implementing the media block actually reduced the HTML size of a stream story by about 50%. So what makes a good component? What do we need? We need correct granularity to solve only one problem with our object. We need it to be flexible and define what we don't know, define how it's going to work in circumstances we didn't originally predict. We want low specificity. We want to make all the rules the same strength, and we want our objects not to interfere with the existing website. We want to define our encapsulation, which means which of the subnodes belong to this object and which of the subnodes don't. So if you have a rounded corner box, if you have a little element to make your corners, obviously that corner belongs to the object it's a part of. You're not going to have a corner floating around by itself. So in that case, you want to use encapsulation. You want to use the cascade to basically target that exact element only when it's inside of its parent. But modularity, on the other hand, means that we want to say that, okay, this is the body of our media object. We don't know what someone's going to put in there. We don't want to define what someone's going to put in there. That's where the edge of our object is. And the next is predictability. If you have a giant pink heading, you want it to be a giant pink heading no matter where it's pasted in the site. You need to make it so that your CSS is predictable, otherwise it can't be reused. So next up, let's talk about integrating components with an existing site. Imagine that we've built a library of little components. We have contours, we have backgrounds, we have content objects, we have a whole library of different things. We can then mix and match those in order to build new and interesting sites that we didn't, or pages or features that we didn't know about when we first started building our site. So I'd like to show you an example. Let me pop out of here. There we go. So I'd like to show you an example from KONGREGATE.com. This is the library that I built for them based on how their website already looked. So it was based on going through their website and finding all the different pieces. We eliminated a bunch of inconsistencies. We found about 299 different heading styles, which is relatively smaller compared to most of the sites I work on. They were relatively visually consistent. But we were able to pare that down to, I think, between 30 and 40 different heading styles and text treatments that they were going to keep. So here we have all the different headings. Their site's interesting in that it has areas which are on a dark background and areas that are on a light background. So we had to make the objects work whichever place they happened to fall on. So we never wanted to end up with a dark H5 heading on a dark background. So we made sure that wouldn't happen. We built them link styles. So they have a default link style, a low light link, mid-light, and highlight. Text treatments, so they had a bunch of different text treatments that they use in different cases. The media block, obviously they needed one of those. Let me see. They also had ads. So they needed to be able to center align, left align, or right align ads. They needed different ad shapes and sizes, so we abstracted that out. They had different images, so they had some with thicker borders, some with thinner borders. They needed spacing classes as well. It turned out in a lot of cases they needed to tweak the amount of space between different objects. And what I didn't want for them to do is to build that into the CSS and to end up with a really unpredictable system where you never really knew what your object was going to behave like. So we built them a way to tweak spacing without breaking the site. They had dividers as well, so just ways of creating horizontal space between two portions of the page. And containers, so a lot of different rounded corner boxes and hover containers and things like that. Okay, so that's an example of the result of visual inventory. So first we saw the visual inventory with all the inconsistencies and everything else sort of played out so everyone could see it. And then we built this component library based on the simplified version of that. The big thing for me this summer, and it was sort of a big realization, was that what I was doing is basically cleaning up after people's crazy code. And I really like that. For me, that's a fun thing to do. Why is everybody snickering? I guess there have to be people who like optimization. Anyway, so if you had a really nasty, messy closet, and stuff was everywhere, it was overflowing, you couldn't even basically fit anything else in. What I realized is that, okay, I have this neat and orderly CSS that I've built, but how do I do it? How do I make it so that they can have both? And what I realized is that by writing my components with really low specificity, I could basically tuck my components in the background of their site. And they wouldn't mess up the existing site because they're not very strong. I don't have really long selector strings. If I have an H1, it's just H1, and that's it, and maybe .h1. But simple selector strings. So I tuck my neat and orderly CSS in the background behind their, well, depends on the site, but it can be a crazy, messy CSS, right? And by doing that, we start being able to build new components build new features with the good components straight away. So any new pages, any new features get built with components straight from the get-go. Then we look at sort of the 80-20 rule, which is to say, probably 80% of your page views are from 20% of your actual pages. So then we start going in and cleaning up just those most trafficked pages or most trafficked features. We rip all the code out for one of them and replace it completely with components. And do that over and over again, and as you do it, your CSS gets smaller and smaller because you can remove the existing CSS, the broken CSS, feature by feature rather than having to redo your entire site in one go. It's basically not possible to redo most sites in one go. We do sort of iterative development now. We don't rip out and replace an entire site with another site. So this allows us to do sort of iterative development where we can have 80% of our site super fast, super performant, really easy to use. And yeah, sure, there's 20% of our pages which are crufty and old and no one has touched in a while. But the first time someone needs to make a modification to that page, what do? They replace the old junk with components, And you have another page which is in the super fast portion of the site. So then the important thing to keep in mind is after you've done that is that you delete the obsolete CSS. Don't leave the junky old CSS sort of running around in there. Once it's no longer used, make sure you take it out. So then I want to talk to you about things machines do well that people kind of suck at. I had done this by hand for a bunch of clients, and finally I was just like, I don't want to do this by hand anymore. So I started thinking about how the more predictable things were, the more I could do them without ever needing to look at their CSS. It was a big revelation to realize that I didn't need to take someone's junky, messed up, broken CSS and move it, migrate it to something good. I could just replace it with the right thing by doing the tucking in the background method. And so in realizing that, I thought, well, actually this is something that I don't have to do at all. It seems like a machine could be able to do this. As well, there's sort of cross-browser testing. Every time we add something to a site, every time we change a feature, we have to be testing on every single browser. And especially with CSS, it's not like you just get to test once at the end. If you're doing it right, you're probably testing with, every few changes you make, you're testing, because if something gets really messy, it's really hard to get it back from there. So we were wasting just a ton of time with this sort of cross-browser testing. How much time do I have left? 5 minutes. Okay, awesome. So there are basically two main pieces. There's linting and there's testing. If we want to test the rendering, it gets much simpler when we have an object that we know how it's supposed to behave. So let's look at the media object. Basically, we know that the width of the wrapper should never be wider than the width of the three containing elements. And we know that the height of the wrapper should always be the height of the tallest child element. Because if it's taller, what happened? It means that something dropped below. And so all of a sudden, we can start to think about testing these objects in a way that means that we don't have to go look in every single browser. It starts to be automated. Linting can give us more information as well. Simple things. I started looking at all the old websites that talk about like the broken box model and things like that, and realizing that most of what it was saying was actually machine testable. So you shouldn't declare width and padding on the same element, or width and borders on the same element. I can parse through the CSS and figure out if someone's done that without ever actually having to look at the site and say, oh, this thing is larger than 100%, clearly there's a box model error. As well, font size increments being more than 2 pixels at a time and never being repeated. I can test that automatically, so I don't have to go through and do it by hand. The key to it is having simple objects that solve one and only one problem. We can't unit test something if everything in the kitchen sink is thrown in. So even in a visual way, we have to break things down so that each object does one clearly testable thing. Grids, for example, are the same as, as the media object. We can test if they're broken. We can test if they're dropping below, because the height of the wrapper should never be taller than the tallest of its child nodes. So looking at that kind of testing as well. So today we talked about the state of CSS performance, building a component library, integrating components with an existing site, and things that machines do well that people kind of suck at. Well, so I'm writing my first JavaScript ever, so I can tell you I kind of suck at that in order to build the CSS lint tool. But it's a ton of fun, and it's starting to test some really basic stuff like broken box models and font sizes and stuff like that. So if the premise is right, if what I'm saying is the way sites should actually be built, to me we should see results. I care a lot about standards, accessibility, and performance and all kinds of things, but what matters to me is, did it change something for my user? Is their user experience actually better? So I wanted to show you some of the results of the Facebook optimization. They found that due to these efforts, we cut our average CSS bytes per page by 19% after gzip, and HTML bytes per page by 44% before gzip. And there are some more notes about other performance projects on the engineering blog. But to me, that sort of speaks for itself. We have vastly less code to deal with as developers, and obviously the site is going to be faster because they're just pushing a lot less over the wire. So these are my contact details. Thank you so much for having me here. You can get me at @stubbornella as well. If you're interested in more of these sort of building of components, check out the open source project on GitHub.